Figuera, once the current completes its function, it returns to the source where taken. Every patent of Buffon and Figuera have this statement. Okay, so I've been working feverishly, sketching my head, different configurations to first of all get the resistor rig, right, to produce alternating current, which I succeeded. Beautiful alternating current. Okay, that was the first step. Then I had to toy around and think about how to stop the reactive power from going back into the resistor, or at least most of it, and get it to go right to the power supply positive, or back to the source. Returns to the source where it's taken. It wasn't taken from the negative terminal, it was taken from the positive. It needs to return to the positive. Okay, so Figuera accomplished this by changing Lenz, or back EMF that happens in a transformer, changing Lenz into reactive power, that it actually goes back to the source where that power was taken from. Now, I'm not there yet, but I have huge progress. So before I start it up, this amp meter is going to measure bridge rectifier output, direct current amperage shorted. It's going to measure. And this meter is measuring direct current coming from the transformer primary, through the multimeter with direct current back to the positive of the power supply. How much we're sending back. Now, I have the secondary open now, so I'm not going to draw any current. This is going to be pure reactive, just like a transformer. As you see, it's like pure reactive. I'm sending nothing back to the hot. And I'm drawing nothing. Okay? And I'm practically using no power, just a hair, the leakage and the flux. Okay. Now I'm going to pull a load. I'm going to short it. I'm pulling 0.24 amperes direct current, and I'm sending back to the positive 0.215, 0.24. Okay, now if you look at the scope, you see this? That's our reactive power that the induction is using, and it's sending it back to the positive, that. So I'm sending 0.215, 215 milliamps back into the positive, and I'm drawing 0.24 milliamps out of the load. So it's real close to 100%, but it's not, because I can't figure out a way to prevent it from splitting and going, some of it going through the resistor. So some of the reactive power is going back through the resistor and burning it to heat. But the large lion's share of it is bypassing the resistor, coming through the meter and back to the positive. So, as you see, once the current, this current that we're taking from the supply, completes its function, it returns to the source where it's taken. Instead of going right to the negative terminal like all other transformers, this wave with the resistor rig mimics a generator. It changes induction in a certain way that the inducted power that you take causes Lenz to pass to the primary, or Lorentz reciprocal, and instead of that going right to the negative and raising your input that much, it puts it back to the positive and brings it down. So this energy is practically free. Now, I'm only using one transformer, and as you saw, Figuera had rows of them and whatnot. I don't know the next step, how to prevent. Now, my input now is 0.57 and 0.24, so less than half. So I'm wasting a lot through the resistor, first of all, obviously. The resistor's wasting, half the energy practically. And, the inefficiencies in the system. But what I'm pulling out, I'm putting almost all of it back. Now I have to go on to the next step to figure out. I don't think you could use regular transformers that have a shell around them. I think you're losing a lot of it through the shell, connecting the negative. It's messing up the magnetism, I think. But anyway, I just wanted to get proof of concept that you can take the lens that's supposed to go to the negative and redirect it to the positive by reworking the sine wave like Figueroa did. So that's what I got. A big step forward. Now I know what I'm looking for. Now I know what the wave got to be to get the action. Now I have to figure out, a little more. But anyway, that's where we're at.